All right, I just wanted to start by thanking all the previous speakers. So basically what I'm going to do, and we didn't plan this out, but basically I'm going to be putting numbers to everything you guys have been talking to, which has been fabulous. So hopefully this will be a good wrap up of the session, and really appreciate everyone for being here and waiting this out. So I'm Nathan Tregger from Verifi. I'm Director of Data Science, and we have a whole data group that looks at a lot of data. So we'll talk about what the data is, how we get it, and then how we try to change some behavior. So just to start off, we'll do a little bit of Marvel here. But my spidey senses are tingling. And why are they tingling? Because they know exactly what slump it is, right? This is one of the things that we've been talking about throughout the day, throughout the morning. And it's really just trying to understand what you think or what you perceive slump is or what you perceive slump should be, right? So I hope everyone got a chance to get at least one Philly cheesesteak sandwich. If not, you still have some time. But there's a difference, right? Sometimes we're looking at from one perspective versus another perspective, and those can be quite different. And then you get into this, basically, what's the real version, right? And a lot of this depends on what you're trying to achieve and whether it's coming from producer, contractor, designer, etc. So I have some data here. This is over 1,000 loads of concrete. And what we're going to do is we're going to measure that slump, and I'll tell you how we do that later on. But we'll measure that slump right when it gets to the site. So as soon as it gets to the site and you're ready, if you have the right slump to pour out, this is what that distribution looks like. All right. This is for same mix design and the same contractor. Okay? So you can already see the range on this is kind of scary. Right? That goes from 2 to 12. And I had to cut off there. When you get to the discharge, okay, so you arrived at site's one slump and then the discharge. So when Tarek was talking about, adding water, adding admixtures, whatever's happening at the site and the time it takes. This is one case, again, same contractor, same mix, 1,000 loads. This is just one of those situations where, hey, I basically ordered a 7, but I really wanted a 10, right? And so you get the same thing. So I'm just putting those, overlaying those on the same graph there, but you visually can see the difference between these two. So that's kind of the base case study for this talk. And we'll talk about how this comes about and then what that affects from a time perspective. All right, so a little bit about onboard sensors. So Pierre did an awesome job. We're a different company. We do this slightly different. We look at the hydraulic pressure and measure the drum speed, and with that we can get a slump measurement. The addition here is that we actually tie this into an admix and water system. So based on what that slump is, automatically, if that drops, let's say, ½ inch below target, we'll automatically add water or admix depending on what the producer or contractor agree on. So basically that tempers your truck so that all along in transit, all the way to the job, it's adjusting, and then at the job, you're ready to pour. So obviously we'll see those benefits in a little bit. This has been around for a while. So last year we did 29, almost 30 million cubic yards. That's the Hoover Dam every 2 months. But for me, the exciting part, we have over 200 million yards through the system. So we have a ton of data to kind of look through. And the interesting thing about a lot of this is, there's a lot of human behavior that you kind of see throughout this. So this is, typical things you want to look at: slump at discharge, water at discharge, total revolutions, discharge temperature. But you have this throughout the entire delivery. So this is a single day in the life of what I get to look at. So you can see how all the activity that's going around in each of these trucks. So generating just a ton of data for us. If we take a quick look at the pressure sensor, right? So this is just how much pressure it takes to rotate the drum. Can I see here? So at the very beginning, I'm looking at this from left to right. You're batching. The pressure spikes because material dropped in there. It becomes cohesive, starts to become flowable. The pressure drops. You see it drive along. It gets to the site, and then eventually it discharges. One of the interesting things, and Tarek brought this up, is that based on this pressure signal and all of the billions of data points that we have, we can actually now start to understand when what we call stealth water is added. So that red hose, right, that calibrated red hose that the driver's adding, we can actually tell when that's happening, first of all. So you can help to retrain drivers, retrain batch people, but we can back calculate what water actually went in there, right? I wouldn't put that, so that there's a lot of things around the accuracy of that water. I wouldn't put it on in terms of from a litigation standpoint, but it's good enough to start to change behavior for your drivers, for your operations. You'd have to do a fluorescence test or something like that to get a little bit more. So let's go back. Let's go back to the slump. You see there, again, delivered 6.5, 7, discharged at a 10. So let's just see where the water is being added. So this is, again, as a histogram. There's a mildly small bar at 0. Ideally, you want to see 0 there the whole time, right? You don't want to be adding water on here. We also, so as I mentioned before, we have the ability to automatically add water if you allow it, and then we have the sneak water. So we're going to take a look at both of those. So this is the manual water that's being added at the site. So in general, they're not using that part of the system. It could be in the instructions to say you're not supposed to, but either way, they're not utilizing this very much. So that means the rest of this is essentially that sneak water that's going in there. So now if we take a step forward and then talk about that 10 minutes of extra time, this is actually the total time on site. So from basically you arrive to the site and then when you're done discharging. So this doesn't count any time that they're just screwing around on the site afterwards. This is once you've dumped your concrete, this is the time that you're on there. So you're going all the way up to 140 minutes. Average cycle time that Tarek was talking about, that's about 100 minutes. It's kind of strange, it's almost 100 minutes no matter where you go. So basically for this job, you're holding trucks that you could have had an entire other delivery for this. These are the customers and contractors that maybe you have the conversation with is, can we change behavior, or maybe at some point you just part ways, because this is the type of productivity that's being wasted on some of these things. So I just calculated average 3.5 yards per truck per hour, and so we'll see what we can do about that. All right. The next part here is, as I mentioned before, you can instruct the truck to add fluids, water, admixture. You can add it up to a certain amount. So obviously, if it's water, you don't want to go above the design water-cement ratio. And so this gets tracked, documented. All of this is available for the producer and the contractor. So basically, a closed-loop feedback system. It's not rocket science, it's not crazy, but when you actually start to manage the loads, the variability goes from what's in the red to what's in the blue, right? And just to draw your attention, the y-axis, this is in millions of loads. So again, this isn't like a lab kind of prototype thing. This has been something that people rely on day in and day out. All right, so the other part that I want to talk about here is and this was discussed before, but with this data, when you're starting to look at this, it's not the blame, we shouldn't be doing the blame game here. This should be about having the discussions to help out both sides, right? So I'm just going to give another case, basically another 1,000 loads here. This is a different contractor, different mix design, but just to illustrate the point. This is somewhere where the contractor and producer agreed on what they wanted to do and how to deliver the concrete. And so you can see basically the arrive slump and the discharge slump are right overlapping. So what that means is that as soon as it gets there, it's ready to go. So if we look at total water again, that bar on 0 is much higher. The manual slumps, they're not doing, or manual system water, they've decided not to do that, or they don't need it. And you get some sneak water here now and then, but that it's very, very minimal. All right, not surprisingly, so I'm keeping the axes the same here for the time on site, you're under 40 minutes, right? So you're shaving on average 80 to 100 minutes off of this, just having those discussions, right? Just ordering the right slump or just realizing what slump you actually need for the job. Yes, and producing it, yes. Yes. So we went from, just to show you, 3.5 yards per truck hour to 17, almost 18 yards per truck hour. All right, so Spider-Man can be teaching himself. All right, so now I have, I'll get us right back on track. I just have a couple of like quick hit things because there's so many things you can do with this now, right? Just having this simple feedback loop, understanding the conversations that you need, having the data to support those conversations. There's a lot of things that can be done. This is the high-speed rail. This is the largest infrastructure project in the EU. They're placing 3 million cubic yards of concrete over the next 4 or 5 years. And one of these things is that the contractor, basically when they had the job, they agreed to testing every single load of concrete. So every single delivery of concrete had to be tested. They quickly, after getting being awarded the job, they quickly reached out to see if there's an easier way to measure slump, especially if it was automatic. And that's kind of where we got involved. The point of this slide, is basically one of the things that came from the producer was if you're going to hold my truck more than 30 minutes, every 10 minutes they're going to charge you $2 a yard, or $2 a minute, sorry. After 30 minutes, they're going to charge $2 a minute after that. So that really starts to add up. So we can actually go through and just see, hey, when did they use the system to measure the slump versus when they manually measured the slump. This is 13,000 slumps, so we have a lot of slump data associated with this project. But the amount of loads over 30 minutes was 40%. As soon as for this project, because of the high importance of this, they tested the heck out of our system to make sure it was accurate. And then last year, they basically switched over to say, hey, we use this system to measure, basically replace the slump test. So after that, I have about 150 points, 200 points here. That reduction has gone from 40% to 22%, right? And that in itself almost paid for the system, never mind the reduction in technicians that they needed to pull with slumps. So that's a big thing, but that's also, you can see the producer trying to change behavior through price, right? And then the contractor is able to get a bunch of that back using technology. This is another interesting one. So this is in California. This is one plant that basically what they did was rearranged their plant. So it was kind of a one-way. You're in a one-way place. You come in, you batch, and then 100 feet later, you have to get out of the plant. All right? So there was no slump rack to sit at for 30 minutes. They had a little bit of a wash down spray, but you basically, if you didn't get out, the trucks behind you were honking. And just to illustrate that, so you were in and you were out. So if we looked at unmanaged loads versus what this is called a load and go, the time at the plant, they average about 4 minutes on plant, right? Which is crazy, getting that out. So it's really interesting. Okay, I think this is the last one. Basically, this graph looks a little bit weird, but on the x-axis is your time, on the y-axis is your total volume delivered. Okay? Each of these little hockey sticks is a truckload. So it starts off flat because I hope they're not discharging on the way to the job. And then it starts to discharge and it starts to angle up. So you can clearly see the left side versus the right side if you get your ducks in order. If you're communicating with the producer, you have realistic expectations about truck spacing. And then also if you're managing those loads to make sure you get to the site and you're ready to pour. This is a curb and gutter mix. This is a very interesting case because the contractors actually own the trucks. This is over in Europe. They own the trucks. They go get their concrete someplace else, but they manage that the whole way, and they're able to reap the benefits for themselves, essentially. So this is going from 85 yards over 24 hours to 200 yards over 10 hours. Right? So it's just crazy. And just, because I'm a data dork, you can start putting some lines here on kind of theoretical things. But you could see, maybe on the left side, the workability went way out of range. maybe it's clogging the system, they had to stop or whatever, but those breaks, really screw up that delivery time. The last part of this project, the last part of this particular contractor was because of the consistency that they were doing and not having to screw around with things, not having to wait on site, but everything was becoming way more consistent with this, is they noticed that they were able to just pull out cement. So they have basically two different mixes. They have a channel mix and a barrier mix, and out of both of these, they were able to pull out for us 50 pounds per mix of cement. Enormous, and still have the rheology, right? You still need to make sure the rheology, especially for these kind of jobs, to be able to place that. So just a combination, I just want to, again, thank all the speakers before, building up to all the different ways that we can improve productivity. And a lot of it is just, around those communications, around those discussions with the different people that are responsible for all the parts of the job. All right, and with that, take any questions.